All right, we're going to get started here with our polar unit video 11. It's the last video for our polar unit. And we're going to be solving equations that have complex solutions. So it's kind of a purpose of why we have all of this stuff. All right, so we're going to start here and just define our purpose. The reason that we study our nth roots is to find the solutions to these equations when we have a higher power and they're going to involve imaginary answers. So in Algebra 2, you were given equations like this: x squared plus 1 equals 0, and you were asked to solve. You were told by your teacher, because it's a quadratic, meaning there's an exponent of 2, that we are going to have to use one of our three methods. We could factor, we could use the quadratic formula, or we could use the square root method. Well, this is a problem that you cannot factor, because you cannot factor the sum, meaning addition, of two perfect squares. You can only do the difference of two perfect squares. We could use the quadratic formula, absolutely possible. We could find A, B, and C. But if you're like most students, you just made a really loud sigh that I mentioned the names or the words quadratic formula. Or we could use the square root method, which in this case is the most efficient way of doing things. So I'm going to subtract 1 to the other side, and then we're left with taking the square root of both sides. When I take the square root of both sides, you'll probably write down plus or minus I if you remembered that when you take the square root you get two answers. But if we think about this, what is the square root of negative 1? Is it both positive and negative I? No, it's typically just I. But because we took the square root in an equation, we had to use positive and negative. So let's interpret this in polar form, because right now we have 0 plus or minus I. We have no real and we have the imaginary part. So to put this into cis form, our polar form, I want to think about the angle that's being involved. The angle that's involved here is a 90 degrees when we use the positive I, and a 270 degrees when we use negative I. Those are the imaginary axis directions. Well, with 0 being the real number, I'm not going left or right at all, and my radius being 1, because I'm only going out a distance of 1, my two numbers in polar form are 1 cis 90 and 1 cis 270. And those are the answers in polar form for our rectangular solutions. So we're going to try this one together. Okay, so this time I have x cubed equals negative 27. The first step that we're always going to take on this is we're going to figure out what the rectangular point is, and we're going to convert that to polar form. So I'm going to, in this case again, use the square root method, and I'm going to subtract 27 to the other side, giving me a place to take the cube root of both sides, where I get negative 3. The cube root of negative 27 is negative 3. So I'm going to then start by looking at where is negative 3 on my axes. Well, I don't have any imaginary answers, so negative 3 plus or minus 0 really doesn't even come into play. Negative 3 is located over here with a radius of 3 at the angle value of 180 degrees. So I can write this as 3 cis 180. But because I took the cube root of this, I am going to have to take into consideration that there might be other solutions to this. And to do that, I'm going to have to use the nth root theorem that we had in our last video with k equals 0, k equals 1, and k equals 3. So I have 180 degrees plus 360 times 0 divided by 3, 180 plus 360 times 1 divided by 3, and 180 plus 360 times 2 divided by 3. Well, my first answer comes out to 60 degrees. My second answer comes out to the 180 we already established, and my third one comes out to 300 degrees. So my three solutions are 3 cis 180, and that's the one we found by just rewriting our simple solution. And then the two imaginary ones, because these will involve an imaginary, because if I'm on a 60-degree angle, I have to involve imaginary and real, not just real. and that would give me 3 cis 60. And then this one over here at 300 degrees would give me 3 cis 300. So these are my three solutions to x cubed plus 27. We're going to go ahead and try another one. Here I've got the x to the fifth minus I. Again, our first step is to get x to the fifth alone to be I. So I want whatever I'm going to raise to the fifth power to simplify to just I, to just the imaginary number I. Well, very similar to our first example, I have to consider where I is located. I'm not going to take the fifth root of both sides here, okay, because the fifth root of I doesn't really mean anything to me, and the calculator doesn't produce a very friendly answer. So instead, I'm going to say, well, where is I located? I is located up here with a radius of 1 and an angle value of 90, so 1 cis 90. That's going to be one of my solutions. But then I'm going to consider k equals 0, 1, 2, 3, and 4. Gives me my 5 solutions that when raised to the fifth power will simply reduce to just I, or just 1 cis 90. Alright, so this gives me 90 plus 360 times 0 divided by 5, 90 plus 360 times 1 divided by 5, 90 plus 360 times 2 divided by 5, 90 plus 360 times 3 divided by 5, and last 90 plus 360 times 4 divided by 5 for my 5 answers of 18, 90, 162, 234, and 306. Again, you may go back and try those on your own or trust that my answers are right, but you do have to know how to calculate that on your own. So my answers, final answers of my fifth roots will be 1 cis 18, 1 cis 90, 1 cis 162, 1 cis 234, and 1 cis 306 degrees. If you were to take any of these, raise them to the fifth power, you would find the final answer would come out to be, whoa, the final answer would come out to be just 1 cis 90. These are all coterminal when you raise them to the fifth power. Alright, our last one here, and I'm going to leave this with you, just some advice to get started. The first thing you need to do is subtract that 1 over to the other side, and then you need to write this into polar form. And what I mean by that is you need to think about where is -1 with no imaginary numbers going to be complex form. Where is that going to be located? Once you have its location, then you need to use your k values to find out all of the other places that are coterminal. And they're not coterminal until you finally raise them to the fourth power. But we will have 4 answers for this question. Alright, please make any comments that you need to, and we will talk more in class.